will see about the Gauss elimination method. Before study of the Gauss elimination method, we require to study some different topic like equivalent form of a matrix that we have discussed in the previous lectures. After finding the equivalent form of the matrix, we should understand about the rank of the matrix using equivalent form. And after that, once we get the rank of the matrix, we should know about the consistency of the system of equations. So after these three steps, first equivalent form of a matrix, second rank of the matrix, and then the consistency of the system of equation, then we go for the solution of system of equations. So all these three properties we will use here in the Gauss elimination method. So all these three you can check the previous lectures. So let's have some example or exercise for the solution of system of equations. Suppose we have given the system of equation. It is x plus y plus z is equal to 9, 2x plus 5y plus 7z is equal to 52, and 2x plus y minus z is equal to 0. So first we represent this system in the form of matrix. So the system of equation we can represent in the form of Ax is equal to b, where A is the coefficient matrix. As you see in the first row, it is written 1 1 1, that is the coefficient of x, y and z of the first equation. In the second row it is 2 5 7, it is the coefficient of x, y and z in the second equation, and similarly for the third row it is 2 1 minus 1 for the third equation. And the column matrix x, y, z is denoted by capital X, and the column matrix that is given 9 52 0, it is the coefficients, a constant that given in the right hand side of each and every equation, that matrix represented by B. So in this way, first we define the all system of equation in the form of matrix. After that we define, so this equation we have given here. After this we define here the augmented matrix that comes from the Ax is equal to b. So what we have done here, the augmented matrix is defined in the form of AB. It is the combination of coefficient matrix A and the column matrix. From here, for the solution of system of equation, we reduce this matrix in the form of equivalent form to check the rank of the matrix and the consistency of the system first, then we go for the solution. In the Gauss elimination, we reduce this matrix AB, augmented matrix, in the form of equivalent form. So for this, what we have to do here, in the first row, first element is 1, and all element below this one we should make it 0. So accordingly we have taken the operation R2 is what? R2 minus 2R1, and we change the R3, that is R3 minus 2R1. So after doing this operation, the second and third row will be changed. So accordingly it is changed 0 3 5 34 and 0 minus 1 minus 3 minus 18. So what we operate in the rows, it is for all augmented matrix and the column matrix both. Now for simplification we have interchanged the row R2 and R3 so that it is changed accordingly. Now we have to make the 0 of the in the third row. So that's why we take here R3 is what? R3 plus 3R2. By using this operation, we get the third row second column element 3, that is 0. So in this way, after calculation, it is 0, -4 and -20. As we see, each row have its non-zero element in the diagonal form, and the left and the below of that element is 0. Thus, this equivalent matrix is in the echelon form. Now we check the rank. So as we discussed earlier, the rank of AB, that is the number of non-zero rows in the echelon form, that is 3. And same if we talk about the coefficient matrix A only, we will have again the same number of non-zero rows in the echelon form of coefficient matrix A. So the rank of A is also 3. Here the rank of A coefficient matrix and rank of AB augmented matrix both are same. Also the number of variables are 3. That's why the system is consistent here. The given system of equations should be consistent and it will have the unique solution, as the rank of A, rank of augmented matrix and the number of variables are same, all are 3. So now we go for the solution. So from this equivalent matrix we represent the equation again, that we get it here. It is x plus y plus z is equals to 9. Similarly, minus y minus 3z is equals to minus 18 and minus 4z is equals to minus 20. From this equivalent system, what we get? Z is equals to 5. From equation 3 we get z is equals to 5. So now we substitute this value z in the equation 2. What we get it here? We get y is equals to 3. Thus we have y is equals to 3 and z is equals to 5. Now we substitute all these two values in the equation 1 and finally we get the value of x, that is x is equals to 1. Thus our solution is x is equals to 1, y is equals to 3 and z is equals to 5, which is the required solution. Thus these steps are required in the Gauss elimination method. So very quick we will see the one more example here. Suppose we have given the equation x plus y plus z is equals to 6, x plus 2y plus 3z is equals to 14, x plus 4y plus 7z is equals to 30. So what we do now here, we represent in the matrix form Ax is equals to b. So it is 1 1 1 1 2 3 1 4 7 according to given equations, and the column is what? Column matrix is 6, 14 and 30. So in this non-homogeneous system of equations, we represent it here augmented matrix. AB, that we can write 1 1 1 1 2 3 and 1 4 7, and the column is 6, 14, 30. So now we reduce this augmented matrix in the echelon form. So the first step, what we required, in the second and third row the first element should be 0. That's why it is R2 minus R1 and R3 minus R1. So what we get the result, that is 0 0 1 2 8 3 6 and 24. Now to make the 3 0, what we get, R3 is what? R3 minus 3R2. So by this elementary row operation it will be 0. So what we see here, all the elements in the third row are 0. So in this case we have the echelon form which has only two non-zero rows. So in this echelon form, what we see, the rank of AB is what? The number of non-zero rows in this echelon form, that is 2, and also same for the coefficient matrix. So the rank of A is 2, rank of AB is also 2, but as compared to the previous example, what we see, it is less than the number of unknowns. That should be, that is 3. So in this case, the given system of equation is system is consistent, but the equation will have infinite number of solutions. To get this infinite number of solution, what we do here, first we rewrite the system of equation according to this echelon form. So here we have only two equations, that is x plus y plus z is equals to 6 and y plus 2z is equals to 8. And since we have two equations and three variables, so the one variable we put it z is equals to k, and then we substitute this value in the equation 2. So what we get it here, y is equals to 8 minus 2k. So after getting these two values, y is equals to 8 minus 2k and z is equals to k, we put it in the equation 1. And finally we get x is equals to k minus 2. Thus we have all three results, x is equals to k minus 2, y is equals to 8 minus 2k, z is equals to k. This is our required solution. Thus we have seen the two examples. In first example we get the unique solution because the system is consistent, and in second, even though system is consistent, we get what? Infinite number of solutions, because this solution is depend on k and k has infinite values. So thus we see the two cases of the consistency of the system of equation. Later on we will see about the inconsistent system where we will not get the any solution. So in the upcoming topic, except this related to Gauss elimination, we will see here Gauss-Jordan elimination method. So thank you for watching this video. Do not forget to subscribe our channel for more update. So thank you for watching this video. Keep smiling. You can comment on the comment box for any more update, more information, any requirement. Thank you.